Hello dear students, let us see the examples for the peptization. The precipitates of FeOH3, if we add electrolyte of FeCl3, Fe plus 3 ions are adsorbed on the FeOH thrice precipitates, which lead to formation of positively charged colloid, that is FeOH thrice adsorbs Fe plus 3 ion and then the colloid is formed. The second example, in the precipitates of AgI, if we add Ki solution, we get negatively charged colloid particle because both AgI and Ki have I minus ion common. So I minus ions are adsorbed on the surface of AgI. So you can see AgI oblique I minus, we get negatively charged particles. In the precipitates of AgI, if we add AgNO3 solution, AgNO3 will have Ag plus and NO3 minus ions. As a peptizing agent, positively charged colloids are formed due to adsorption of Ag plus ion, because AgI and AgNO3 have Ag plus ion common, so the common ion is being adsorbed and AgI adsorbs the Ag plus ion and positively charged colloid is being formed. This is how we can understand the peptization. Now we will study about the purification of colloids. When we prepare the colloids, there are so many impurities present into the colloids. How we can remove these impurities? Let us try to understand. Colloid solutions, when prepared, generally contain excessive amount of electrolytes and some other soluble impurities. Present of traces of electrolyte is being needed. Traces means in a very small quantity or in a very small amount, is essential for stability. See, electrolytes needs to be remain present, but they should be remain present in traces, that means in a very small amount. But if they are present in a larger amount, they even cause the coagulation of solids. So the same is, whereas larger quantity of electrolyte causes coagulation of colloid. Therefore it is necessary to reduce the quantity of electrolyte from the colloid to requisite minimum. Now what is requisite minimum? Let us try to understand that what is the meaning of requisite minimum. Requisite minimum means to the level of quantity which is required to stabilize the colloid, but that is the minimum quantity that is required. The extra quantity we need to remove. So let us understand the definition. The process used for reducing the amount of impurities to a requisite minimum is known as purification of colloids. So this is what it is, the definition for the purification of colloid. Purification of colloid is done by the various methods. The first method that we have is known as the dialysis. The first method that we study for this is dialysis, a process of removing a dissolved substance from a colloidal solution by means of diffusion through suitable membrane is known as dialysis. In like for dialysis, we arrange this kind of situation. We have a vessel. From this vessel, we pass the dispersion medium from the bottom, and the dispersion medium can go out from the top of the metal, from the top of the vessel, from the opposite side. So this is the inlet for the dispersion medium. This is the dispersion medium outlet. Here we have a dialyzing membrane, a bag-like structure in which we have a dialyzing membrane. This dialyzing membrane may be a pig's bladder, it may be parchment paper, or it may be cellophane membrane, and we have this colloid filled inside it. This dialyzing membrane allow only the dispersion medium to pass through, but the dispersed phase, that means the dispersed phase, that is the colloidal particles, they cannot pass through this dialyzing membrane, and this is how we can do the process which is known as the dialysis. Let us read what I have explained. Dialyzing membrane may be animal membrane like pig's bladder, or a parchment paper, or a cellophane sheet. True solution or dispersion medium can pass through the dialyzing membrane, but colloidal particles, that is dispersed phase, cannot pass through the dialyzed membrane. Now we'll understand what is dialyzer. The apparatus used for dialysis is known as the dialyzer. So whatever we can see in the figure is known as the dialyzer. As you can see in the figure, that a bag of suitable membrane containing the colloid is suspended in the vessel through which dispersion medium can pass, but dispersed phase cannot pass through. The dispersion medium continuously flow through with which impurities that is electrolyte or soluble impurities can be reduced from the colloid. So by passing the dispersion medium, we actually reduces the electrolyte or we reduces the soluble impurities by passing the dispersion medium. While the level of electrolyte reaches the requisite minimum, the process of dialysis is stopped. So this is how we can understand about the purification of colloid. I hope, my dear students, you are enjoying your studies. Happy learning.